tell you that they will deliver the world. And I have a lot of friends in that.
Last presentation for the day, building with the end in mind, ensuring a seamless transition from area to system-based construction. I'm gonna leave it with you, Jay. It's a pleasure to open for the presentation. Thank you so much.
Thank you, Silvana. Good afternoon, everyone. Welcome to the final session, I guess, of the AWP conference, Building with the End in Mind. Great transition from our last presenters that we just had. I'm not Ted Blackman, although I've got his Astros jersey on. We are excited to present today, and there are a lot of things that are common with what we're trying to achieve with Building with the End in Mind. I'll pop this slide up. I'm not going to read from it, but I think you'll recognize some of the things that you see on the screen. We as owners in the industry understand very well that the project in itself is not complete until it's operational. We have many examples, and it's not just in oil and gas. This is if you looked at other industries such as even the airline industry with the building of in the UK of Heathrow Terminal 5 and the operational problems that had from that. You can look that up on your time. It's if we don't have the operational aspects covered in the overall project process, we're not going to achieve the return on investment that we hope to. Much of our success in projects depends upon the operational production coming up as planned. So there's often delays that we see in the industry, and AWP plays an integral part in that. There's no doubt about it. And I think that's what we hope to maybe explain as we go through this session today. In this session, we're going to have speakers. Mick Hayashi, he's the EPC DX Department Chief Advisor for JGC. Robin Mickelson, the President of the AWP University. Yogesh Srivastava, who's the CEO of Technobuild, and all of these individuals have many years of experience that you've already heard them in previous sessions, so no need for further explanation, but they will be presenting to you today. I'm just opening this session up, and I'll just move to, I'm Jay Mosier with Shell, PTE for construction, and also our global AWP champion. So when we transition from area-based construction to systems construction and completion, there's oftentimes many things that can impact that, and they almost always do. I think AWP in itself, along with the digital solutions that we have to supplement the benefit now, can help us in this arena tremendously. So the bullets on the left are things that I think will resonate with you, and you look at them. You know, do we have the test packs aligned with the system work packages? Well, what is the view of the contractor versus the owner? I mean, oftentimes, we'll have an EPC who has responsibility for commissioning, and that does put extra onus on them to perform in terms of getting ready for operations. But we often, as an owner, have a completely different perspective than the EP, and for sure from the C, depending upon their contractual obligations. When do we need to have the commissioning started? When does systems completion started? You always hear these percentages that are out there in the industry, and there's nothing wrong with those. I mean, those historically in the past are good data points. Is it 65%? Is it 70% complete with construction that we start commissioning? I personally think AWP, if done correctly, will tell us that. We do need to be cognizant that disciplines such as mechanical and electrical instrument all have a little bit different view. So we need to make sure this alignment that the last group talked about in the last presentation is in place, that everybody understands it. The real interesting fact I want you to take from this slide is that if you look at the left, you'll see the arrow there. That's designation of roughly 50% of the duration of the project left. But yet you look at the time constraints, our time constraints are 50% left, and if you look, you're 75% complete with the project. So 25%, the last 25 takes 50% of the time, and that's, we've got to change that. That cannot continue. We can do it though. There's an impact when you have this situation where everybody's rushing, you're trying to complete, you affect HSE, you affect quality, you affect all the things that AWP provides benefit toward get affected by these schedule constraints. Okay? So there are a lot of tools available we can use to manage this transition. You know, AWP, the unconstrained IWPs, and obviously the SWPs, and this is from the final report 364 that was recently issued. And Robin will talk more about that in this presentation. And as I said, the digital part can be a drastic improvement and support of completions. I don't want you to look at terminology on here, but I'll just give you an example, visual example of what I'm kind of referring to here. If you look at this chart, you'll see this is a construction-driven schedule or progress-driven schedule. And on the left, you'll see the systems. That's just representing different systems that might be need to be commissioned. So you can see how staggered this might be in an area-based construction. But when we move to the system-based or system completion-driven schedule, you want to align it in the way you're going to operate and how does it need to come up. And obviously, these two are drastically different. So if we don't begin with the end in mind, then our chances of success drop drastically. The other thing I'll add that Ted maybe didn't add in this last session that I think is critical is not always just operations, and I'm talking about maintenance and turnarounds. You think about the longevity of a project and how maintenance should use the information that we build during construction, during execution, and should have access to that makes their life, they should be able to go in and operate and maintain this facility without pause. They should be able to have their digital twin in place. So whatever we do in execution should support that effort. I completely agree with that. And lastly, I think from an operations, the turnaround perspective, how often do we, have to take these units down? Well, we're taking these operating processes down on a 3 to 6 year interval, and all of this information should be used. There's nothing worse than going to a project that you've successfully implemented, and then you get there 3 years later and nothing has been utilized. That no tools have been utilized, no databases, no processes that you put into place have been utilized in the construction between commissioning, the startup, and the next turnaround. We want to have consistent use of whatever products that we deliver to operations, maintenance, and turnaround on an ongoing basis, so we can utilize that long term. I'll just end with this fact that we can have a successful project as defined by IPA, and there's many of them. The project can just look wonderful on paper, but IPA is not measuring how the production process comes up and how you are against your production promises. And that's what we need to strive to get better at. So with that, I'm going to turn it over to Mick. Mick?
Thank you, Jay. Hello, everyone. I'm Mick from JGC. Hello from Japan. Good morning here. Okay, let's just get started. Okay, my presentation focuses on the foundation for smooth transition from area-based to system-based. So I'm going to really talk about the prerequisite that to get ready for the smooth transition. So first, I'm going to talk about tags and master code structures. And second, I'm going to talk about master tag register. And third, and critical transition points to control in MPC. Okay, so what we have been targeting is that we are not going to do, we do not because we can do it, but we should do what we should do. That means following the path of construction. So that means do not proceed with the work just because we have enough material and drawings, or just because we want to achieve the earned values. Okay. The second, do we know exactly what we should do next or the next? And third, how to determine the priorities and sequences by AWP planning and build and monitor the plan down to the tag level. That's very important keywords. Tag, by tag, I'm talking about all the tags, equipment tags, instrument tags, including process lines and cable numbers, civil and building tags. Okay, so now prerequisite tags and tag class. This is just a foundation of knowledge, a very simple entity relationship diagram showing tags and tag classes. Okay, so one tag belongs to one tag classes. One tag class has many tags. So like an example, tag K001 belongs to tag class compressor. Tag P010A belongs to tag class centrifugal pump, and tag G001 belongs to tag class generator. That's understandable. Everybody understand this. Okay. Now, I'm going to talk about 3 coding structures. There's no plural here. Okay. Now, first of all, area breakdown structure. In other words, we call it CWA, construction work area. Like A000 has second level A100, third level 110, and B000, and so forth. Second coding structure is system breakdown structure. Like a plant system is actually assembled into systems and subsystems, sub-subsystems. Okay, so what we are going to talk about is a smooth transition from area breakdown structure to plant system breakdown structure. However, what we introduce is one more coding structure, which we call a functional breakdown structure. So it's, in other words, you can actually, it's similar to disciplines or probably the organization, but what we are talking about is, it's like what we are doing for example, detail engineering. Are we doing civil engineering or equipment engineering, piping or instrument or construction? Okay, so I'm going to grab these 3 coding structures to explain Tagmaster. Okay, so now I just talked about 3 dimensions, which actually represented by interrogatives. That means where, why, and who. Probably many of you knows that 5 W's, but then I'm going to talk about it in the next slide. Okay, so what we have done is we created tag class and tags at the center, which explains what dimension. And then each tag has a pointer to work area breakdown structure, and plant system breakdown structure, and functional breakdown structure. So that means we covered 4 of 5 W's. Then after we schedule this, for example, installation, then we're going to cover another dimension, last dimension of when. So that means, say we have a K001 compressor tag belongs to a tag class compressor, as I explained, which belongs to CWA B120 and belongs to system PU41A20 and designed by discipline rotating equipment. Okay, so this is very simple foundation. So I'm sure everybody is doing this. Okay, so lastly, this is scheduled to be installed on 15th October, 2 years later. Okay, so now the 3 dimensions, that means we can construct 3D cube. Okay, as you could see, one axis, area WBS, which explains where, functional WBS explains who, and system WBS and why. Why means is that certain tag, why is it there? Actually, I'm talking about the purpose of the tag, and from an engineering perspective. For example, pump serves for giving pressure to the liquid or the line. So that's why I use the term why. Anyway, a lot of tags are actually placed in the cross section of these three dimensions. And then if we have 3D cube, we have 3 planes. One is area times versus system, and second, area versus discipline, and third, system versus discipline. So tags are the common divisor for all the 3 dimensions. Okay, now I'm going to talk about one by one. So plant areas versus plant area systems. But then this is an imaginary plant. And as you can see, the areas are disassembled into 3 main areas, A, B, and C. And then the utility lines and process lines are designed like this. So each circle is actually representing tag. Okay, so we have CWA, and we have systems, and then we have tags. Okay, now let's move on to the first plane, showing which CWA covers which plant systems. Okay, you can see this. All right, I just put the small picture here. Okay, this is a matrix, and all the tags are placed into certain cells. So this means tags are the common divisor. Second plane, which is versus area versus discipline. Okay, now CWP is actually at the cell of cross section. Okay, CWP is broken down into IWP, which has many tags. So if you actually name one tag, you know exactly this tag belongs to which IWP and which CWP, and which belongs to which area and which system, or which functional breakdown structure. The last plane is system versus discipline. Okay, now we have lots of system work packages. Okay, one system work package belongs to one plant system breakdown structure and a functional breakdown structure. Okay, now SWP has lots of tags. Again, one tag, if you actually pick up one tag, you know exactly which system work package has this tag. Okay. Now, after I talked about these 3 dimensions, 3 core dimensions, then let's look at critical transitions in EPC phases. Okay, here, okay, the above portion is more system-based, bottom is more area-based. Okay, engineering starts from process equipment, blah, blah, blah. This is very rough flow, and then construction, startup, and O&M. Okay, as you can see, engineering starts with system-based concept, and more down towards the area-based. In another word, is start with a conceptual and then move down to physical. And then after they finish layouting, piping and civil, then we start construction. So as you can see here, the area-based engineering and area-based construction, which is the starting point, as very critical point. And then moving upwards, and piping, equipment, pressure test, loop test, and commissioning, and turnover as system. Okay, this is actually very similar to V development concept, which can be used for software engineering as well as construction. Okay, now I point out one first critical point that actually RT 364 explains this. So we have to have a SWP in mind first, beginning with the end in mind. Okay, then planning, back casting to CWP, back casting to EWP, then executing the other way. Okay, so the second critical point is that I call it AWP critical because, for example, civil tags are created last but used first in construction. Piping and welding volume controls the project duration. So this is the probably occupy first 50% of the progress. So now the last portion here is a transition critical. So as Jay pointed out, this point actually occupies another 50%, even though the progress achievement is not as much as the previous one. That means we can do the very bulky work here, but then when we move upwards, then each system must be complete in very precise way. We cannot even have any leak. Just one leak is not allowed. So that's why we have to be very careful. But at the same time, progress is very slow, which we would like to improve. Okay, now I only talked about these 3 dimensions and critical points. So our solution in JGC is that creating or building tag master, which contains all the tags. Sometimes huge project contains 500,000 tags or even 1 million tags. Then as soon as engineering starts, or even from feed phase, we start building tag master. Of course, it starts with equipment tags, and then move on to instrument, electric, and then finish with the civil and pipings. Of course, as engineering have a lot of changes, so we have to incorporate all the changes into building, incorporating into the tag master. And then we have to keep maintaining this tag master until the end. Okay, so this is the key, in our opinion, that we keep track with all the tags. That means each tag containing CWA, a plant system, and functional breakdown structure, as well as schedule. So this is the key information to support smooth transition. At this, we can feed those enough information to the people for construction and commissioning startup people. Okay, in summary, okay, I explained 3 master code structures. All of them are hierarchical, and then which includes CWA, plant system, and disciplines. Each tag carries those 3 applicable codes and attributes. Second, we keep master tag register. Tags are the common divisor of construction area, systems, disciplines. Every tag resides in the cross sections of 3-dimensional cube. Each tag is bound to EWP and CWP, IWP. Of course, I didn't talk about PWP, but it's also bound to PWP with the display information. And tag completion statuses, planned and actual, can provide either area-based or system-based anytime you want to see. So that's very important. At least the people knows which system we can actually start first or get ready by when. Then I mentioned 3 critical points. One is scheduling criticalities, milestone control by backcasting. This determines turnover priorities. Second, critical paths of area-based engineering, civil and piping to construction. Okay, we often fail to even start AWP just because these civil tags are not ready when we actually want to plan civil works in the construction phase. And then lastly, transition criticalities will be managed using path of construction, which is the sequence, is determined by the priorities of SWP. The sequences are planned and tracked by CWA and plan systems, which are bound to every tag in the tag master. So this is actually very, very important, how to keep track with precise, accurate, and timely tag master register. So this is what I like to say. Okay, thank you very much. With that, I turn it over to Robin.
All right, thank you very much, Mick. It's always a pleasure to listen to you present, Mick. Thank you very much. And there's some very good points in there, especially the critical point aspects. I love those bases. So let's jump into it, shall we? Jump past my first slide here. Sorry, don't get click happy. That's what Steven said. All right. So as we continue to present on this, my name's Robin Mickelson, president of the AWP University. I'm not going to get into a long-winded introduction for myself. Most of you have heard me or talked to me before. So let's jump right into it. I am going to try and do CII's FR364 report some justice. In this presentation, I'm going to focus on it from the point of view of the SWP and how it affects how we change some of our planning efforts. Mick touched on it slightly, but it's a nice new tool that's just emerging that we should all get involved with and start to understand. I know us at the AWP University, we're feverishly building a course around the basis of SWP use as we speak. So I love QR codes. So please scan the QR code on the screen. If nothing else, save the location from it. That is for the location of the 364 research information. Please go give it a read. I was not part of that team. There was a lot of very smart people on that team. I was on 365 at the time, but great research that was done there. Please give it a view. All right, so let's jump into that research and where all the research came from that was brought into play when they started talking about what do we do for commissioning? How do we start to bring AWP methodologies forward into commissioning, and what do we need to do that? And thus was the birth of the SWP package that we're going to talk about a little bit more. Another QR code, if you're interested in looking for the research surrounding AWP, more than just 272, this is going to take you to the main construction execution page, which is great for giving you all the different directions. So as we cite the research that we're presenting here, just to make sure that you can go access it. Of course, to access it free, you have to be a member. Otherwise, join, get a membership. You can get it, or you can buy the research information as a non-member. But a lot of very important research was monitored and elaborated on for this research team from RT364. And there was a lot of great things that were brought forward. Let's look at some of that research. And one of the things that gives us some detail, and as we kill you with death by bullets, we'll look at the basis of what is an SWP. Everybody keeps asking that question. So these are direct excerpts from the research, and we're going to take a look at the basis of them. So an SWP is a deliverable that enables a commissioning work crew to perform work in a safe, predictable, effective manner. Sounds very much like an IWP definition, does it not? That's not by mistake. That is not by coincidence, I wouldn't think. An SWP should be scoped to be manageable and progressible, and is typically scoped in a way that maps existing commissioning zones, systems, subsystems, or subsystem components. So we're going to talk about that a little bit more. We're going to show some graphs and how those kind of tie in. Basically, what we're saying is an SWP is typically scoped in a way that existing systems, existing commissioning zones, parts of them or a hole will tie to these SWPs. And we'll talk about the mapping here right shortly. An SWP should be mapped to predecessor IWPs in order to ensure that the path of construction enables efficient startup. What do they mean by predecessor IWPs to an SWP? An SWP is a scope of work, a grouping of data. If we're talking about piping, it's say flange to flange, a test area. It's a grouping of data, a grouping of components within the piping world or other worlds that we can get our head around and isolate. So think about it from valve to valve, think about it from flange to flange, think about it from blind flange to blind flange, those types of things. And why do they say predecessor? Because the IWPs, as they're completed, roll to the SWP completion in a many to one, and it's a partial IWP, many partial IWPs to one SWP, meaning, remember, IWPs are area-based, meaning that as area-based IWPs, they were going to have multiple different systems represented within an individual IWP. And we're going to talk about the mapping here, where it's going to take several IWPs to make up one SWP, and then we track that relationship, and we'll show that. Predecessor IWP completions and constraints are monitored and mitigated prior to SWP issuance. An SWP should contain the necessary documentation supporting workface execution. Why is that? Why is the documentation got to migrate through? Because the SWP becomes a building block for the turnover package. It becomes a mediary between the IWP and the turnover package, and multiple SWPs will make up that turnover package to help drive that efficiency forward. So SWPs should be approved by the responsible stakeholders, and any constraints should be mitigated. Just like an IWP, we need to constrain analyze them and make sure that they are executable. We're also doing that at the IWP level to roll those to the SWPs for maintaining and monitoring those constraints. All right, so as we get past the death by bullet, now that we have a good basis and description of what an SWP is, let's take a look at where that fits in to the basis of our typical process flow for AWP. And my screen is not advancing. Stephen?
Go ahead and give me 1 sec here. Just make sure things are okay. Okay, go ahead and try it again. Click once in the viewer and then.
It really wants to stay on death by bullet here. No,
I wonder if it's because I have a pop-up. Sorry about that. Okay, try that again. Interesting. Sorry, one moment. I'll try one other thing. Okay, try it one more time, please.
not working, Stephen. Can you just advance it for me and I'll direct? Oh, there it is. Did you do that or did I?
That was me.
Okay. If you could just stick with us, and I'll just get you to advance it if it's not working for us, so that we can continue on. All right. Sorry for that little interlude. Technology is both a helper and a hindrance often, so we will move forward. So I promised, how does the SWP and commissioning and turnover in general fit into the overall process diagram? You've seen this several times through the conference already. I brought it up earlier with a presentation that I was giving on work package relationships. I think Ted Blackman had it in one of his presentations, and I think I saw it in another presentation earlier, given by Fleur, if I'm not mistaken. But it is a great drawing. We've modified it a little bit now to bring in the system work packages. So let's talk about this real brief. I'm not going to go through it in its entirety, but this is a lot of arrows going in a lot of different directions to show relationships and the circular means of different packages affecting other packages, if you will. Starting with the systems, moving to then construction work area identification. From construction work area identification of those geographical packages, we move into construction work package development, and so on. Then, of course, breaking it down into the IWPs, while we have influence from, of course, our systems, our turnover packages, our engineering deliverable schedules, our procurement schedules. And then, of course, what we're here to talk about, turnover and commissioning, system work packages being not just a one-way influence, but a two-way influence of mapping in the systems. So a system work package contains, as we mentioned earlier, parts of multiple IWPs and the priorities of the system turnover and the mapping of those IWPs to that system work package. I'm oversimplifying it a little bit, but I'm trying to keep it rolling. Will influence the installation work package priorities. So installation work package priorities set based on how we're going to turn it over, how those systems are going to be compiled from these system work packages, and then of course tied to all of our constraint management from both the system basis, engineering deliverables and procurements, as well as of course construction work packages that are tied supposedly and should be on a one-to-one to our level 3 schedule activity. We put that all together in a bag, shake it up. We should have a pretty well constraint-free, analyzed, executable basis that gives us a walk into commissioning like we may not have had in the past. And what I mean by not have that walk into commissioning like this in the past is that prioritizing IWPs by the system work packages, completing the system work packages by multiple IWPs rolling into those system work packages, that gives us the ability to, in essence, skip that whole painful phase of that. We like to use the term the 70% change from area-based construction to systems completion. We're still going to monitor that. We're still going to maintain it. We may shift priority around that time of the project, but it's going to be more seamless because the system work packages are going to carry and the system work packages are going to carry our priorities through the life cycle of the package and the sequencing and the schedule. So that as we move through, we continue to ensure that the right IWPs are being executed to support the system turnover. And the system work package is our tool to do that. All right, so next slide, please. As I'm clicking away. All right, so this is just a real brief little diagram that comes directly from the research, just to show you what I've been saying, the multiple different IWPs, and how those multiple different IWPs or portions of those IWPs contain that turnover documentation and roll into each of those SWPs, if you will. And this is a little bit misleading possibly because it's not the entirety of each IWP, as I've said multiple times. It's portions of those IWPs that will make up the entirety of that SWP. All right, and next drawing, please. Let's look at a workflow for what this really means. And trust me, I'm not going to go through the workflow box by box. I'm sure a lot of you would like me to. I love flowcharts, it's kind of my thing. But this flowchart really gives us an idea of how we develop those SWPs, where the SWP development comes from, where you sequence them, where they affect the IWPs and the systems through mappings and relationships, where those scopings happen, and then we approve the baseline schedules based on the influence of those. So this is a great tool to reference later, but we're not going to go through it line by line, if you will. Let's get to some more eye candy and take a look at what we're really talking about in moving the SWPs around. So next slide, please. When we look at this, these came directly from the research. Fernanda, one of the research academics, was very proud of these. They were great drawings to identify and give example of what we're talking about. As I've said multiple times, and I'll keep saying it multiple times, IWPs or portions of those IWPs compile the SWP, which is the mediator document between turnover and the IWP execution. So let's look at what that looks like graphically. So what do we mean by graphically? What's it look like? If you look at the chart on the left, the drawing on the left, and how all the IWPs are color-coded to identify which portions of this. And now, let's not look at it for the entirety of the scope. Let's just look at it for the colors in the example, because it is a little bit small scope. We wouldn't typically have this small scope or these small of SWPs. But you get the idea, it's an example. So when we look at it, you can see each of the SWPs over here on the right and the IWPs on the left. And if you look at the color coding, you can very well see that. Let's look at the red to start with in SWP1. You can see that the red in SWP1 is made up of IWP6, it's made up of IWP4 or a portion of IWP4, as we've said, nearly the entirety of IWP6 and nearly the entirety of IWP5. So when we look at that, you can see kind of how that maps. Now, why is this mapped in this way from these SWPs? Remember, we're using clear breaks within the physical environment, meaning we're using blind flanges or valves to isolate the particular system. Why are we doing that? Because as an SWP, it should also follow your testing program so that we can sign off that SWP as complete, roll it up to the turnover. We don't have to dismantle it again for testing or those types of things that will follow on a one-to-many type testing basis for those for the environment and the components. So you can see this is a very isolatable test, if you will, although we're not going to test through a pump, but you can see in the example the idea that we get here. All right, so let's move to the next slide as we get through this. And this, we're showing now the turnover systems. So multiple SWPs are going to roll up to the entirety of a turnover system, if you will. So and you can see in this case that we've got a representation of SWP 4, 5, 6, 7, and 8 as the commissioning system and the commissioning zone, if you will, for this area. So it gives us a much more granular control and tracking against our commissioning. And that's what this is really all about, right? Today, especially our conversation here, we're ending out the day with commissioning. How fitting is that? So we need to identify how and what the best and most efficient way is to tie our IWPs to our turnover systems, hence enter the SWP. All right, so next slide. We've talked about, and I've said it, and I'm going to keep saying it, portions of IWPs rolling up to SWPs. This is a good representation that comes directly from the 364 materials that shows kind of that quilt of mapping between IWPs and the SWPs, so that we can see very clearly that, you know, we're going to scope our IWPs based on the way we're going to build this thing. We're not going to scope it based on other influences. The most efficient way for that crew to actually execute that IWP is the way we're going to build the IWPs. Thus, we're going to cross constraints of SWP. So you can see that IWP1, portion of it makes up SWP1, a portion of it also makes up SWP2 from at least a constraint point of view, and the execution of IWP2 and IWP3 as well as 4 make up, or portions of those make up the SWP constraints. That mapping at a component level is extremely important. You know, Jay is famous for having said, it's all about the data. The only way this works is by mapping it and controlling that data. Those relationships through the data is extremely important for understanding what IWPs roll up to an SWP. So yes, Jay, it is all about the data. And to make this process work, that's exactly what has to be driven forward here. So because I love flowcharts, I'm going to end it off my portion of the presentation anyways with another one. So Steve, please show us the final slide. Now, this is another work scope and another flowchart to show. The first one was about system work package development. Now, this is about work scopes and tied to the SWP. So how do we identify what the scope of that SWP is? How is it going to be identified? Are we going to follow test extents all the time? How are we going to consider a testing program involved in it, as well as our system turnover package? All of that we start to look at through this type of a workflow and our inputs and outputs from this type of activity. So again, I'm not going to go through the entirety of these. I wish I could. We don't have enough time. As I said, I love the flowcharts, but for future reference, we can look at these, and this gives us a great aspect into how these SWPs actually are developed. So with that, I will turn it over to our next presenter, Yogesh. And Stephen, if you could advance, and I guess Yogesh, you're going to share your own. So take it away, my friend.
Thank you. Just sharing my screen here quickly. Are you able to see my screen? Assuming it's a yes.
You're good.
You are. Yeah, you bet.
Good. Thank you. So yes, now that you know from an owner's perspective why this last bit is also quite critical, Mick explained the philosophy behind it, the coding structure and how it all gets done. And Robbins also explained the the framework within which CII has put this all together in a very systematic way. Since the beginning, when we coined the AWP, the end in mind was commissioning and startup. And as you already know now that as Mick talked about an area-based work breakdown structure and a functional control work breakdown structure, I think it's a similar way I'm presenting you, but I'm going to share with you the execution part of it. Now you know the theory, the best practice, but taking an example how this gets done digitally in an execution sense. Because quite often, otherwise, when you look at commissioning, it seems like another big vault of data with all kinds of checklists populating it one by system, and comes so late in the game. So how can we execute this in tandem with the area-based construction? That's where I'm going to give you a little bit of a journey based on some practical examples. So what we focused on is, as you see, the area base 1, 2, 3, 4, 5 gets me till the area base built for by IWPs. But what's important also is based on the plant startup, is the definition of system packages and the turnover commissioning packages or the binders that will be within which I believe the system work packages are a subset. These are the ones which have to be thought out early in the project. And the boundary definition, how many commissionable, non-commissionable for process, for electrical, for instrumentation, etc., and the coding structure, etc., needs to be arrived at early. So this is what you already understood from Mick. But when it comes to really doing this, that end in mind should also be right in front of you, the end in sight. And that is where you can, as the earlier you start with seeing what did commissioning in terms of the system and subsystem has created boundaries, how many of them are there, and how have they grouped it, and what will be the Ttriple C point. If that is in front of you in an integrated manner within your area-based execution system, sorry, keep messing this. Okay. That is where you are able to start seeing the end in mind to end in sight. So one important part is to establish the Ttriple C. What will you turn over? Is it at construction complete or mechanical complete, or do you have an integrated team which involves the pre-com and then you will turn over? Establishing this orange flag of the Ttriple C is a very important step early in the game, because there is organizational complexity. There may be people from another party, a third party, owners team, etc., that become part of this. So establishing that is an important part, and along with that, a very essential element is the safety in transition from where you are either in a greenfield type construction environment, but now you've going into a safety in transition type of role versus full operating permit that is required when you're moving off into the next stage. So important is also, as you did your path of construction early in the project, where you defined the boundaries of what is a CWP by an area, etc. This also is important that you start establishing a definition at a higher level. What will be your boundaries? And quite often it might be by systems, by pressure rating and others, depending on the discipline you're involved in. You carve out what will be your high level boundaries, and of course down within there you get to the next level of the subsystem level test pack definition. Again, the 3D modeling tool, and one which we are using also allows you to start selecting and identifying the breakpoints from where to where are you creating your test packs. And a correlation between area to subsystem, as was illustrated earlier, it is quite easy if you follow the scheme as Mr. Mick mentioned. You can quite soon start correlating which engineering is done by system until you go to other disciplines, but you can very quickly start establishing the correlation between area-based EWPs to the system or subsystem. And quite quickly, when it starts getting the when aspect of it, the 5 dimensions that were shown earlier, you start seeing the visual, you start visualizing when are these things to be turned over and what will be the period when this will be done. So end of the day, from digitally managing it, you have got the installation work packages where you're finishing the IWPs, but at the same time, there are many supporting things required in terms of safety, permit services, and equipment that to basically open up what we call in the turnover commissioning package module, where you're managing the safety and other things and taking it all the way into your the registers where all the information is now finally documented. So quite important in this whole process is also to have a visibility to a punch list, an integrated punch list as much as possible. Otherwise, what is remaining work, whether it is B check sheets or a C, all that is, there is work that is not done, work which is defective, and work which is basically not done right. So there are different types of things that come up here from a quality perspective. So important to have an eye on the punch list is quite a way to increase the efficiencies around getting things done. So with that much, I would pause here and allow ourselves to get some questions as a team. I do not know how much more time is left. I'll stop here.
Great, thanks for that, Yogesh. Steve, could you throw up the Slido slide? And yeah, if you could just take a picture of the Slido slide and then start putting your questions up. And we've already got a couple. First, should a team, what should a team do if the owner does not have a commissioning team yet when the schedule is being developed at the end of feed? And if they don't award an EPC company this scope of work? So who'd like to respond to that?
Punt. That's difficult. I mean,
Yeah,
ideally,
I think the first thing they would do is,
yeah, you would never get to, ideally, you would never get to that point, but obviously it happens. It's a real question. Don't mean to demean it at all, but quite often, yeah, we don't focus on commissioning until we're too far along in construction, and we miss the opportunity to sync these together. I think the realization is here. That's why we're having this conversation. Okay, there's no doubt about it. We underestimated it in the past. We continue, if you look at the historical data with production curves and our production promises that we made, we tend to not meet them. And there's many reasons for it, but it has to be integral to the process of construction. It has to be integral to the process of execution. So I would say, you know, it should be brought up, whoever's bringing it up. Maybe the contractor brings it up. It doesn't really matter. It's got to be addressed sooner than later.
yeah.
All I'll add here is, regardless of whether you got the scope or not, it is important that you at least provision for it in your platform and systems, that if it is bought in, you can go back in and have the attributes populated, and you have placeholders for it, whether it is 3D modeling or whether it is your PNID mockups, etc.
Mm-hmm. So I think with this question, the nuance to read into it is, I mean, on the surface, the first thing I would do here is cry. If there's no commissioning team in place, do we have a schedule? Do we have a turnover schedule in place? Maybe we don't have a full commissioning team, but we have a plan from the owner on commissioning, which we can start to build from and start to work our packages from and start to get a prioritization for, while the commissioning team is actually starting to take hold as we get into construction. But if neither of those things exist, a commissioning team nor a schedule, then we fall into exactly what Jay is saying. Chains need to be rattled and doors need to be knocked, right?
But if we're following the process of AWP, those of us who've been through this all week, all last 2 days, we should have these coding structures that Mick went over today. We should have what Yogesh went over today. We should have those things early from an E&P perspective, where the commissioning should give input to that. But regardless if they don't, you still have the coding structure in place to be able to react to it. So you have to have that initial process data and operational data that says, I'm going to build a path of the construction around how I need to operate it. I don't know a facility that doesn't need steam, air, water, and utilities to start immediately. So I mean, we are professionals. We've done this we know, at least at a starting level, what we've got to start with. But hire a retiree, get somebody who's not in the business, do something that's going to add value.
So, right, Jay, I mean, we are positioning that the boundaries may get established late or they may change as well.
Yep.
But that's fine. I mean, we are still floating with it at this point. And so the boundary definitions will be coming later on. But at least we have provisions for it and take it in as soon as they get defined. And the other part is the organizational Ttriple C clarity. That also comes late in the game, how far do I take it and when does commissioning take over? That kind of a thing.
So let's go to the next question. For brownfield projects, would there be some instances when we should start from systems rather than work areas? Or is it always the best practice to go from work areas and then switch to systems?
Do you mind if I take that one first, y'all? I mean, is everybody okay with that?
Yeah.
Yeah, I heard this has come up in quite a few of the discussions during the last 2 days, and I think it goes back to not so much the definition of brownfield, but it is scalable AWP. If we're doing a project that's small enough, and we do them down, $500,000 or less, it can be done. In those cases, yes, you might have one construction work area that encompasses the entire project. Okay, so there's nothing wrong with that. This is about, do I implement the full AWP systems here, or do I just focus on piping, steel, and workface planning? I mean, that's a choice you need to make. But you need to have that conversation early. You need to understand that going in. Brownfield projects, almost every project we deal with tends to be brownfield. It could be a mega project in terms of capital, but yet integrates into the system of an existing facility. So I think in this question, I think someone's trying to get to is more about portfolio level projects, small projects that have fewer systems, if you will, and that's how we would handle them. I mean, everybody can handle them differently.
Okay, and I think we have time for one question, but we actually have two questions that I think are related. The first one says the SWP is still unclear. How does it relate to a test package? And then the second comment is, shouldn't test packages be one class of an SWP? So I don't know if you want to tackle that one, Robin?
I sure can. I would tackle that one with the fact that Mr. Blackman came in and answered the question, which is that, an SWP, I'm sure the overall concept is still somewhat unclear, as I was flying through the information pretty quick on a year and a half's worth of research. So I suggest, checking out their research. But the concepts have been around for a long time, as in one of the follow-on questions Mr. Blackman refers to also. And we've used very similar methodologies to the SWP. We're just finally in the official world of CII putting a label around it and putting some clear detail to it. And 364 has done a pretty good job of doing that. How does it relate to the test package? Obviously, when you're into the stage of about to turn this over as part of a commissioning package or a turnover package, the test is part of it at that time. Obviously, the hydro tests, they will roll up to it, and that needs to be tracked against it. With an SWP, a lot of people promote trying to stay within the boundaries of a test for the scope of an SWP. I tell you that's probably not going to be the state of most SWPs, at least in my mind, coming from the cold, frigid north, living in northern Canada. In northern Canada, glycol is expensive to handle, pump, and test with, but it's obviously necessary. So when we start talking about test packages, we often cascade test passes, hydro tests. We try to bring as many tests together. So our testing program becomes very blurry on how we group tests together to be the most efficient with the handling of the glycol when we're in really cold situations. So it will get a little bit blurry there, but I think as Ted had said, an SWP as part of, or a class the test as being a class of the SWP is very important to follow that same PQ rationale that Mick was showing us about. So hope that may have rambled a little bit.
All right.
Yeah, I was just going to say, let's hand this back to Silvana and thank the team for a great presentation. Lots of good information. Silvana?
Thanks, team.
Yeah, thank you, Lloyd. All right, Sif, can you